Our project is a data gathering system that uses a quadcopter to bring wireless communication to sensors in the field. Here's an overview of our system functionality. Let's start with an example flight over Hutchinson Field on the UC Davis campus. Our quadcopter will follow instructions for an automated flight. No manual control is needed except running the program. First, the quadcopter does an automatic takeoff from the starting point and begins to travel to the first beacon. Here, it reaches the first beacon and detects the beacon's Bluetooth signal. Once a connection is established, the beacon sends data to the receiver. After the data transfer is complete, the quadcopter continues its flight. The quadcopter flies over the remaining points and gathers the data at each one. Then, the quadcopter returns home and lands. Our data gathering system uses technology from Cypress semiconductors. This is our beacon. It uses a PSOC4 to control sensors, memory storage, and Bluetooth communication. It also uses a power management IC from Cypress that manages inputs from batteries and solar panels. This is our receiver. It uses a PSOC4 for Bluetooth communication and a PSOC5 to store data and communicate with the flight controller. Now let's see all of these components work together in a real experiment. We've placed beacons in the hallway spaced far apart. Now we start up the quadcopter and the receiver. Note that we have no propellers on the quadcopter right now because of the safety concerns. As we walk down the hall, the receiver will connect to each of the beacons in order. Here's the data we got from the experiment. From the flight controller output, we can see that the receiver connected with all the beacons. Now we unload the SD card. You can see the data from moisture, humidity, temperature, and ambient light, as expected. We would like to thank Professor Knosen and Cypress for sponsoring our project. We would also like to thank Jonathan Mars for being our project mentor.